We are being directly targeted by a black hole. It's 657 million light-years away, so don't worry. It won't snare us. PBCJ 2333.9, or simply PBC to make things simpler. This galaxy has been reclassified after researchers found that the supermassive black hole at its center has turned and is now facing our galaxy. Scientists began investigating this galaxy as they became aware of its unusual characteristics. They made numerous measurements to support their notion, which was that the relativistic jet of the supermassive black hole had altered its course. PBC was formerly classified as a huge radio galaxy because it once blasted out jet material on either side that was a whopping 4 million light-years across, or nearly 40 times the size of our own galaxy. It came as quite a shock to observers when they glanced into it and saw that PBC was pointed right towards Earth. It indicates a galaxy that has rotated 90 degrees, converting it into a blazer, a galaxy point with a jet pointing in the direction of Earth. The two gigantic lobes on either side of the galaxy created by the black hole's jet material are the most spectacular feature when observed with radio waves. We can assume that the lobes are old since the nucleus is not feeding them. In contrast, the structures visible nearer the nucleus are more recent and functional jets. Uncertainty surrounds the cause of PBC's axis alteration. One possibility is that PBC collided with another galaxy, changing its axis. This discovery shows how little we actually understand about black holes, let alone the universe, in either circumstance. What do you believe? Feel free to comment down below and make sure to subscribe to our channel. You are watching Call of the Cosmos. Now, coming to the more concerning part that you are eager to listen. As said earlier, this black hole pointing directly at us does not pose an immediate threat to our planet. Supermassive black holes are incredibly far away from Earth, with the closest one being located about 26,000 light-years away in the center of our Milky Way galaxy. Even with the supermassive black hole pointed directly at us, its gravitational effects on Earth would be negligible. Furthermore, black holes do not emit any light or radiation that could harm us. Instead, they are detected through their gravitational effects on nearby matter, such as stars and gas. So, while a supermassive black hole pointed directly at Earth would certainly be a fascinating astronomical phenomenon to observe, it would not pose a danger to our planet, and yes, we need to learn a lot more about the topic. While it's highly unlikely that a supermassive black hole would start coming towards Earth, but if it did, it would take millions of years for it to approach us, and we would likely have plenty of time to prepare and take action. However, let's assume that a supermassive black hole is indeed coming towards Earth. In that case, the view from Earth would gradually change over time. Initially, the black hole would appear as a distant point of light in the sky, much like a star. As it gets closer, its gravitational pull would become stronger, and it would begin to distort the light from stars behind it, creating a phenomenon known as gravitational lensing. The closer the black hole gets, the more pronounced this effect would become. Eventually, the black hole would get close enough that its tidal forces would start to affect the Earth. This would cause the Earth to deform, stretching it out into an elongated shape. As the black hole got even closer, its gravity would become strong enough to tear the Earth apart. This would happen well before the black hole actually made contact with the planet. The Earth's material would be gradually sucked into the black hole's event horizon, which is the point of no return, beyond which nothing can escape the black hole's gravity. While this scenario is highly unlikely to happen, if it does, will it be the end? What would we see while falling into the black hole? Let's explore. The Milky Way contains over 100 million black holes, but detecting these has been extremely difficult. However, in April 2019, the Event Horizon Telescope saw the first ever direct image of a black hole, a supermassive black hole, at the center of the giant elliptical galaxy, named M87. The boundary of a black hole is known as an event horizon. Although not a physical boundary, it is a point in space beyond which it is impossible to escape the black hole's gravity. Once something passes the event horizon and falls into the black hole, it can never come out of it again. If you fell into a black hole, theoretically speaking, gravity would stretch you out like spaghetti, though your death would come much before you reached the singularity. But what if you could enter a black hole? How would you do it? The first thing would be to choose a supermassive black hole like the one within M87, which is over 3 million times wider than Earth, to visit. This way you would be very far from singularity when you went over the event horizon, about 12 billion miles far. You would float for a long while and may even last as long as a year before you reach your end. What could be avoided though are black holes with accretion disks? Only about 1% of supermassive black holes accumulate these fast-spinning rings of matter. As we saw earlier, they can heat up to 1,000,000 degrees and create large magnetic fields. Such powerful magnetic fields would instantly shut down your nervous system and stretch your atoms into thin rods till you dissolved into oblivion. If you had to visit such a black hole, then it should be entered perpendicular to the disk, far from the edge of the fiery ring. As you near the black hole, you'll see the light of the universe warped by the black hole's intense gravity. The sky will have streaks of light from the stars, and because the black hole bends the light that bounces off it, you might see duplicated objects around you. You will see the entire formation and history of the black hole since its inception. The concept of time slows interminably near a black hole's intense gravity. For the real world, you have slowed so much that you appear frozen, as if seeing as an image on the event horizon. However, for you the motion of the universe has accelerated. If you look back out as you float toward the singularity, you may see the universe go past you, only without you in it. Far-fetched and beyond the realm of theoretical physics as of now, there is one means of escape. If the black hole becomes a wormhole, it could take you into another part of the universe. Spaghettified, no doubt, but who knows, there could be someone or something on the other side that could pick up the pieces of your destroyed quantum information and make you whole again. So, wanna go inside a black hole just like in the movie Interstellar and see what happens? Let us know in the comments. And to know how accurate the interpretation of the black hole in the film is, feel free check out our other video. And if you haven't subscribed to our channel, please be sure to subscribe to Call of the Cosmos. Thanks for watching, we will see you again very soon.